Welcome to Interesting TV. Black holes. Black holes are fascinating and mysterious objects in the universe. They are incredibly dense regions in space where gravity is so strong that nothing, not even light, can escape from them. Here are some key points about black holes. Formation. Black holes can form through the gravitational collapse of massive stars. At the end of their life cycles, when a massive star exhausts its nuclear fuel, it undergoes a supernova explosion, leaving behind a dense core. If the remaining core's mass exceeds a critical value, around 3 times the mass of the Sun, it collapses further to form a black hole. Event horizon, the boundary around a black hole, where the escape velocity equals the speed of light, is called the event horizon. Once an object crosses the event horizon, it is trapped within the black hole and no information can escape from it. Sizes. Black holes come in different sizes. Stellar black holes have masses a few times that of the Sun, while supermassive black holes are found at the centers of galaxies and can have millions, or even billions of times the mass of the Sun. Observation. Black holes themselves are invisible, as they don't emit any light. However, they can be indirectly detected through their effects on nearby matter, such as gas and stars orbiting around them. Hawking radiation. According to Stephen Hawking, black holes are not entirely black due to quantum effects. They can emit a form of radiation called Hawking radiation, causing them to slowly lose mass over time. Time dilation. Near a black hole, time is affected by its strong gravitational field. Time appears to slow down for an outside observer observing someone or something falling into a black hole. Role in galaxy evolution. Supermassive black holes are thought to play a crucial role in the evolution of galaxies. Their gravitational influence affects the motion of stars and gas, shaping the structure and dynamics of galaxies. Why black holes exist? Black holes exist as a natural consequence of the laws of physics, specifically Einstein's theory of general relativity, which describes how gravity works on a cosmic scale. When massive stars reach the end of their life cycles, their fate is determined by the interplay between gravity and the pressure generated by nuclear fusion in their cores. Here's an overview of why black holes exist. Stellar evolution. Stars, like our Sun, shine brightly due to the energy released from nuclear fusion in their cores. During most of their lifetime, the outward pressure from the fusion process balances the inward force of gravity, keeping the star in a stable equilibrium. Nuclear fusion. As a star exhausts its nuclear fuel, primarily hydrogen, the fusion reactions slow down, leading to a decrease in the outward pressure. Gravity takes over as the fusion slows. The outward pressure can no longer counteract gravity's relentless pull. The star begins to collapse under its own gravitational force. Supernova explosion. The collapse of a massive star results in a catastrophic event known as a supernova. This explosion releases an enormous amount of energy, temporarily outshining an entire galaxy. Remnants. What remains after the supernova depends on the mass of the star. If the core's mass is less than about 3 times that of the Sun, it will become a white dwarf. If the mass is between 3 and around 20 times that of the Sun, it will become a neutron star. However, if the core's mass exceeds the critical value around 3 solar masses, its gravity becomes so strong that it collapses to a single point, forming a singularity. This point is surrounded by the event horizon, beyond which nothing can escape, creating a black hole. Where is black hole is located? Black holes can be located throughout the universe. They are not confined to specific regions but can exist in various locations, including within galaxies, in the empty space between galaxies, and even at the centers of galaxies. Here are the main types of black holes and their typical locations. Stellar black holes. Stellar black holes are formed from the remnants of massive stars that have undergone a supernova explosion. These black holes are relatively small. With masses typically a few times that of the Sun, they can be found within galaxies, often in binary systems where they interact with other stars. Intermediate mass black holes. Intermediate mass black holes have masses ranging from hundreds to thousands of times that of the Sun. Their existence is still a subject of ongoing research, but they are thought to be found in the centers of some globular clusters or smaller galaxies. Supermassive black holes. Supermassive black holes are the largest type of black holes, with masses ranging from hundreds of thousands to billions of times that of the Sun. They are commonly found at the centers of most large galaxies, including our own Milky Way galaxy. These black holes play a crucial role in galaxy formation and evolution. Primordial black holes. Primordial black holes are hypothetical black holes that could have formed in the early universe, shortly after the Big Bang. They are much smaller than stellar black holes and might have masses ranging from tiny fractions of a gram to many times that of the Earth. However, their existence has not been confirmed, and they remain a subject of theoretical study. How many black holes in universe? The exact number of black holes in the universe is currently unknown and challenging to determine precisely. Black holes are notoriously difficult to observe directly because they do not emit light or other forms of electromagnetic radiation. Instead, scientists detect their presence indirectly by observing their gravitational effects on surrounding matter such as gas and stars. However, based on current estimates and observations, there could be a vast number of black holes in the universe. Here are some key points to consider. Stellar black holes. These are the most common type of black holes, formed from the remnants of massive stars after a supernova explosion. There could be millions or even billions of stellar black holes in our galaxy, the Milky Way. Beyond that, there are hundreds of billions of galaxies in the observable universe, each potentially hosting millions to billions of stellar black holes. Intermediate mass black holes. The existence of intermediate mass black holes is still being studied and confirmed. However, if they exist, there could be a significant number of them in globular clusters and smaller galaxies. Supermassive black holes. Supermassive black holes are found at the centers of most large galaxies, including our own Milky Way. The exact number of supermassive black holes in the observable universe is difficult to estimate accurately, but they are believed to be numerous. Primordial black holes. The existence of primordial black holes, which might have formed shortly after the Big Bang, remains theoretical. If they exist, they could be distributed throughout the universe in large numbers. Thanks for watching Interesting TV. Like and subscribe.